Hello friends, I welcomes to all of you once again in our next lecture of complex number. Our today's lecture is really very important and I think you also enjoying because now examples related to the complex number. First see the instruction: express following complex numbers in the form a plus ib. And now we know that a plus ib is actually general form of any complex number. Okay, so let me write each and every complex number as z. Z is the symbolically representation of a complex number. So first one is z is equals to, as per your textbook the first question is this: z is equals to 5i into bracket minus 3 by 5 into I. This is the given thing, 5i into minus 3 by 5 into I. And let me multiply this result easily. So here what is this complex number z? I can say that this 5 cancel. So 5 cancel and what we get? Minus 3i square. See, 5 cancel, I is multiplied there. And therefore z is what? Z is now minus 3 into minus 1 because I square is minus 1. It means z is equals to 3. C is the real number, 3 is the real number, but we have to express each number as a plus ib. So therefore this z can be written as 3 plus I into 0. So a number is a plus ib. This is of the form a plus ib, right? It means you compare, a is 3, B is 0, but do not compare here, just we have to write or we express it as in the form a plus ib like this. Okay, now second question is this: z is equals to, a given complex number is I raised to 9 and plus I raised to 19, my friend. I raised to 9 plus I raised to 19. Okay, here is very interesting because I raised to 9. So we know that in the previous lecture we had already discussed about powers of I. So here we may apply that result. We know that I raised to 8 is 1 or multiple of 4 is 1. See here, I just write a nearest value to 9 which is multiple of 4. It means we have to write here a nearest value to 9 which is multiple of 4. So I can say that I raised to 9 is I raised to 8 into I raised to 8 into I raised to 9. Similarly, what about the nearest value? I raised to 16 and I cube, because 16 is also multiple of 4, right? 8 is also multiple of 4. So therefore this z is 1 into I plus 1 into I cube. So therefore z equals to I. And what about I cube? I think you know that what is I cube, right? I cube is minus I. You know that? Okay, I just write here plus I cube is minus I square into I. That's why minus I, as we know from the powers of I. Therefore z is I minus I, 0. Actually this complex number 0, and yes, 0 is also complex number. We may write it as 0 plus I into 0. So z is equals to 0 plus I equals to 0 is the complex number, or this is your answer. Now the third one, a complex number z is equals to I raised to minus 39, my friend. I raised to minus 39. Okay, so I just write here z equals to 1 upon I raised to 39 minus 39. So 1 upon I raised to 39. Now again I just write nearest value to this 39 which is smaller than 39 and also multiple of 4. So that is I raised to 36 into I cube, right? And therefore this complex number z is 1 upon I raised to 36 is 1 and this is minus I, my friend, right? I cube is minus I. It means this number is minus 1 upon I. But again, see here, in denominator complex number is not possible, so applying surd, multiply and divide by I. Applying surd. Here I applying surd. Now therefore, what is Z? See here, minus 1 into plus I is minus I in numerator. Denominator is I square. So that is minus I upon minus 1. So is plus I. Plus I actually there. Okay, I will give you another method. If you are not satisfied with this, see here, I just give you another method. Or I think you can enjoying the another method. Let us see. Or this Z is equals to, see here how I solve it. Z is equals to I raised to minus 39, right? See, I just give another method. 1 upon I raised to 39. આમાં તો કોઈ ડાઉટ નથી. હવે બરાબર જોજો, 1 can be written as I raised to 40 upon I raised to 39. I write the reason. Reason is 1 is equals to I raised to 4. આ તો બધાને ખબર છે ને, 1 can be written as I raised to 4. So therefore from this multiply by power 10. So 1 raised to 10 is I raised to 40. We may write, and therefore in place of 1 I can write I raised to 40, and hence prove Z is I. See, 40 by 39 I. And I, how can we write I? I we may write 0 plus I into 1. See here my friend, you have to express it as Z equals to A plus IB. So that's why Z is equals to 0 plus I into 1. We may write this. Now the fourth question is, Z is equals to 3 into 7 plus I7 plus I into 7 plus I7 once again. This is a complex number. You have to express it as a form A plus IB. So again, first of all, let me take common here. તો તમને calculation તો આવડે છે ને? With the simple calculation, let me solve it. Here a complex number Z can be written as 7 plus I7 is common here. See, from this both. So remaining term is 3 plus I. It means you have to multiply this now finally. Z is equals to 7 into 3 plus 7 into I. This 7 is multiplied plus I7 into 3 plus I7 into I, right? Now just to multiply this, 7 3s are 21 plus 7I plus 7 3s are 21I and plus 7I square, right? 21 plus 7I plus 21I, that is 28I. 7 plus 21 is 28. And this is, my dear friend, minus 7. This is minus 7. The reason is what? I square is minus 1, imaginary number. And now finally your answer, 21 minus 7 is 14 plus 28I. So you just write it as A plus IB. A plus IB is the complex number. A very simple calculation is there. It means you have to calculate in that manner, you can easily solve. Now fifth question. Let me derive it, but you have to solve in homework. 1 minus I just write the question. Minus in the bracket minus 1 plus 6I. So you easily solve it in homework, right? Express it as A plus IB. Sixth one, Z is equals to 1 by 5 plus I into 2 by 5 minus in the bracket 4 plus I into 5 by 2. See here, this kind of expression is there. Okay, so let us solve it. A simple subtraction is there. So z can be written as 1 by 5 plus 2I by 5 minus 4 minus 5I by 2. Now write the terms of real part together and terms of imaginary part together. So therefore, first of all, I just write 1 by 5 minus 4. This two term. There is no I in this two term. Now from this two term, I is common. From this two term, I is common. So 2 by 5 and minus 5 by 2 remains. 2 by 5 minus 5 by 2. What is this? Here we have to take LCM. 1 minus 20 by 5. 5 is clearly multiply here. 5 4s are 20. 1 minus 20 by 5 plus I into. Again we take here LCM as 10. See, it means cross product. 2 is multiply there. 2 2s are 4 and minus 25. Finally, a complex number Z is. This is minus 19 by 5 plus I into minus 21 by 10, which is of the form Z equals to A plus IB, and this is your answer also. So I think you easily solve such kind of question. Now the next one or next question is question number 7. But now this question is once again in homework. Z is equals to, see the question my friend, 1 by 3 plus I into 7 by 3. This is I into 7 by 3 plus in the bracket 4 plus I into 1 by 3 and minus in the bracket minus 4 by 3 plus I. I hope that you easily solve because calculation is there. So you have to solve yourself. Now question number 8. Z is equals to 1 minus I whole raised to 4. Now power 4 is there. What to do with this power 4? Let me write this complex number Z as 1 minus I whole square into 1 minus I whole square. I think you easily understand that, or 1 minus I whole square square, right? Actually, I have to write it as 1 minus I whole square square. It is power 4. And we know that what is expand of perfect square. First term square minus 2 times first and second term plus second term square square, right? 1 x minus y whole square is the similar term. Z is equals to 1 minus 2I minus 1 my friend whole square. I square is minus 1. This is hero of the chapter. I square is minus 1. Minus 1 plus 1 cancel. What is square of this? Minus 2 square is 4. Remember that. And I square. Minus 2 square is plus 4. I square is I square. And what is I square once again? I square is minus 1. It means this answer is minus 4. But we have to express as A plus IB. So minus 4 plus I into 0. Okay my friend. So this is the thing here. It's very easy. Now the next question. Question number 9. A complex number Z is equals to 1 by 3 plus 3I whole cube. So is x plus y whole cube. And you know the expand is what? Z is equals to first term cube x cube plus 3 times first term square and second term खबर છે ને x cube plus 3x square y plus 3xy square, right? This is the expand of perfect cube and plus 3i cube. I hope you know the expand very well. You just learn this kind of sum in standard 8, 9th, 10th level. So primary level is this: x cube plus 3x square y plus 3xy square and plus y cube. Now just expand it. 1 by 27. See here, 3 cube plus 3 3s are 9i. See here, 3 3s are 9i into 1 by 9. See, 3 square is 9. Plus here 3 3 directly cancel. So this is 9i square. And plus 3 cube. Again 27 and I cube. Right? A simple thing is this. Okay, this 9 9 also cancel, my friend. 1 by 27 plus I only plus 9 into minus 1, this I square, plus 27 into minus I cube. Now just write the terms of a real part. It means 1 by 27 minus 9. Okay, and plus I minus 27i. That is what? That is 1 minus 9, 27s are, I do not know, let me multiply. 9 7s are 63, 3 6, 9 2s are 18, 18 plus 6 is 24. 1 minus 243 by 27 and minus 26i. Finally, this complex number can be written as, what is this? Minus 242 by 27 plus I into minus 26. Okay, so I think you easily understand this question very well. Okay, now question number 10. I just give you in homework, 10th one. Z is equals to minus 2 minus I by 3 whole cube. I think you easily apply again perfect cube and you can solve it easily. So all 10 questions are completed now, but I think you try to solve this question yourself, right? Calculation is there is no any another thing relative to this question. So I hope that you enjoying this lecture with the help of I square is minus 1, which is hero of this chapter. So remember that hero. Okay, these all are villain related to them and you have to solve it. Okay, so all the questions are related to calculation as completed. In the next lecture, now we will deal with the inverse of any complex number. Okay, till then, be safe and thank you very much.